So today we are going to evaluate this integral, and the expression is 1 over 3 plus 3 sine theta plus cos theta, and we have to integrate this with respect to theta. So we have an expression which is a fraction, and it involves sine theta and cos theta, but we can't rationalize it because we have three terms in the denominator. We can rationalize or try to rationalize an expression or a fraction when we have two terms in the denominator. So rationalization is not the way here. Next we consider substitution, and I did try substitution here, but that didn't work. So we need to use some other method, and basically I should say that normal substitution didn't work here. There's a special substitution called Weierstrass substitution, in which we substitute for tan theta over 2, we substitute t, but we don't have tan theta by 2 here. We have sine theta and cos theta. So we basically need to calculate the value of sine theta and cos theta and d theta also when t is equal to tan theta by 2. And this substitution is generally used when we have a fraction, and that fraction involves some expression which has sine theta cos theta in it, and other methods fail. So then we use this substitution. And I said that we need to find the value of sine theta and cos theta when we say that tan theta by 2 is equal to t. So here's a right angle triangle, and it has an acute angle theta by 2. And as we are saying that we are saying tan theta by 2 is equal to t, so tan of anything is basically perpendicular over base. So in this case, perpendicular will be t and base will be 1. So as we are interested in sine and cos theta, we need to find the third side of the right angle triangle, and we can find that third side, which is hypotenuse, by simply using Pythagoras theorem. And it states that hypotenuse squared is equal to base squared plus perpendicular squared. So hypotenuse squared is equal to, base is 1, so 1 squared plus perpendicular, which is t. So hypotenuse squared is equal to 1 plus t squared, and we are interested in hypotenuse, so we'll take the square root. So we get the hypotenuse equal to square root of 1 plus t squared. So we are interested in cos theta and sine theta. So here the angle is not theta, it is theta by 2. And we need to write the expression for cos theta by 2 first in order to find cos theta. So cos theta by 2 is equal to, cos of any angle is basically base over hypotenuse. So base is 1 and hypotenuse is square root of 1 plus t squared. So cos theta by 2 is equal to 1 over square root 1 plus t squared. Also, we have this identity which links half angle to double angle, and if we write the formula for theta by 2, it is equal to square root of 1 plus cos theta by 2. Basically we have half angle on the left hand side, and on the right hand side of the formula we have double angle of that angle. So if we have theta by 2 on the left hand side, we'll have theta on the right hand side. If we have theta on the left hand side, we'll have 2 theta over on the right hand side. So cos theta by 2 is equal to square root of 1 plus cos theta by 2 according to that formula. And now we have two equations in terms of cos theta by 2, so we can simply compare them. So when we compare both equations, we get 1 over square root of 1 plus t square is equal to square root of 1 plus cos theta over 2. So we are interested in cos theta. So we'll square both sides to get rid of the square roots. So squaring both sides, we get 1 over 1 plus t squared is equal to 1 plus cos theta over 2. So we just need to find the value of cos theta from this equation. So 2 over 1 plus t squared is equal to 1 plus cos theta, and we are interested in cos theta. So we'll separate cos theta from here. So it will become 2 over 1 plus t squared minus 1. Next we'll take the LCM, and LCM here will be 1 plus t squared, and in the numerator we'll have 2 minus 1 plus t squared. So this negative sign will distribute and it will give us 2 minus 1 minus t squared, and we are left with cos theta is equal to 1 plus t squared over 1 minus t squared over 1 plus t squared. So we have found the value of cos theta. So in order for us to evaluate that integral, we need three things: cos theta, sin theta, and d theta. So cos theta, we have found the value of cos theta. Now we need to find the value of sin theta. So cos theta is equal to 1 minus t squared over 1 plus t squared, and sin square theta, as we know, that is equal to 1 minus cos square theta for any angle. So from this, sin square theta is equal to 1 minus t squared over 1 plus t squared whole squared, and this whole square, it becomes 1 minus t squared whole squared divided by 1 plus t squared whole squared. So we can just simply take the LCM, and it will become 1 plus t squared whole squared minus 1 minus t squared whole squared over 1 plus t squared whole squared. So we'll be left with, we'll simply expand these formulas, and when we expand a plus b whole squared, we get a squared plus b squared plus 2ab. So we get 1 plus t4 plus 2t squared minus 1 plus t4 minus 2t squared. So this negative sign will simply multiply, and we'll get 1 plus t4 plus 2t squared minus 1 minus t4 plus 2t squared. So 1 and negative 1 cancel out, t4 and negative t4 cancel out. So we are basically left with 2t square plus 2t square, which gives us 4t square over 1 plus t square whole squared. And we are interested in the value of sin theta, not sin square theta. So we'll take the square root. So the value of sin theta will be 2t over 1 plus t squared. Simply take the square root, and sin theta will have the value 2t over 1 plus t squared. Now we need to find the value of d theta, so we can evaluate that integral. So as I mentioned that we have used the substitution tan theta over 2 equal to t. So from here we are interested in d theta, and for that we need to separate theta from this equation. So for that we need to take tan inverse of both sides, and When we take tan inverse of both sides, we are left with tan inverse of t equal to tan inverse of tan of theta by 2. So tan inverse and tan, basically they are uh, inverse functions, so they cancel out. So we are left with theta by 2. So tan inverse of t is equal to theta by 2, and now we need to move this 2 onto the left side, so we'll be left with this 2 was being divided, so on the left side it will be multiplied, so 2 tan inverse of t is equal to theta. So now we have theta, and we just need to find the value of d theta, and for that we need to take the derivative of this equation with respect to t. So taking derivative of both sides with respect to t, we have d theta over dt is equal to 2 times the derivative of tan inverse of t. So it is d theta over dt is equal to 2 times 1 over 1 plus t squared, as tan inverse of the derivative of tan inverse of any variable is basically with respect to that variable is 1 over 1 plus that variable times squared, or that variable squared. So here we were taking the derivative with respect to t, so it will be 1 over 1 plus t squared. So d theta over dt is equal to 2 times 1 over 1 plus t squared, and we are interested in d theta, so dt will be moved to the other side, and on the left hand side it was being divided, it will be multiplied on the right hand side. So d theta is equal to 2 over 1 plus t squared times dt. So now we have all the things which we required, the value of sine theta, cos theta, and d theta, and now we can simply plug in these values and transform our integral in the form of t, because we have found the values of all these things in terms of t. So our integral becomes the integral of 1 over 3 plus 3 times, it was 3 times sine theta, so it will become 3 times 2t over 1 plus t squared plus cos theta, so cos theta was 1 minus t squared over 1 plus t squared times d theta, so d theta is 2 over 1 plus t squared times dt. And we need to do some simplification in the denominator. So 1 over, when we take the LCM of these three fractions, we get 1 plus t squared, and in the numerator we get 3 times 1 plus t squared plus 3 times 2t, which is 6t, plus 1 minus t squared. So we get 1 over 3 plus 3t squared plus 6t plus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt. So when we simplify the numerator of the fraction in the denominator, we get 1 over 3t squared minus t squared becomes 2t squared, and plus 6t plus 1 plus 3 becomes plus 4, and when this fraction is being divided by 1, when it is multiplied with 1 it gets inverted, it becomes 1 plus t squared over 2t squared plus 6t plus 4, and 1 plus t square and 1 plus t square cancel out, so we are left with 2 over 2t square plus 6t plus 4. So we can see that in the denominator we have a quadratic expression, and we'll see that we can use middle term breaking in this case or not. So we need to find two factors, two terms which solve to give us 60 and which multiply to give us 80 square, and indeed we have two such numbers, and those numbers or terms are 2t plus 4t. So we break the middle term in 2t plus 4t, and when we take 2t common from the first two terms we get t plus 1, and when we take 4 common out of the last two terms we get t plus 1. So when we take t plus 1 common, we get 2t plus 4, and we can take 2 common from 2t plus 4, so it becomes 2 over t plus 1, 2 common, t plus 2. So 2 and 2 cancel out, so we are left with 1 over t plus 1 times t plus 2 dt. So we now have our entire integral is transformed into this simple integral, this fraction which has two linear factors in its denominator. We just need to use partial fraction resolution to convert this fraction in the form of a sum or a difference of two fractions. So we can use linearity property of the integration to just evaluate their values. So we'll be doing partial fraction resolution, and 1 over t plus 1 times t plus 2, we have linear factors, so we can write them in the form of two separate fractions having these factors as denominators. So a over t plus 1 plus b over t plus 2, and we need to find the values of these a and b in order for us to write this fraction in the form of this combo of two fractions. So we need to multiply this equation with t plus 1 times t plus 2. So we are left with 1 is equal to a times t plus 2 plus b times t plus 1. And when we multiply a with this factor and b with this factor, we are left with 1 is equal to at plus 2a plus bt plus b. And when we take t common, we have a plus b and plus 2a plus b as constant. So we are interested in the values of a and b, and for finding those values we need to have some equations, and we get those equations by comparing the coefficients of the variables on both sides. So we can compare the coefficients of t on both sides. On left hand side there is no term involving t, so we basically have the coefficient equal to 0, and on the right hand side we have a plus b, so a plus b is equal to 0, and when we compare the constants on both sides we get 2a plus b is equal to 1. So we have two equations here. We just need to solve these two equations to find the values of a and b. So I'm subtracting both of these equations and subtracting 2 from 1. So changing the signs of the equation written below this a plus b is equal to 0. So plus turns into minus in the second term, also plus turns into minus, and in the last term we also change plus to minus. So we are left with plus b and minus b cancel out, so a minus 2a is minus a, and 0 minus 1 is minus 1, so negatives cancel out, so we are left with the value of a, which is simply 1. So we need to find the value of b now, so putting this value in equation 1, which is a plus b equal to 0. So putting in 1 we get b is equal to minus 1. So we have the values of a and b now, so 1 over t plus 1 times t plus 2 is equal to a over t plus 1, which was 1, so 1 over t plus 1 minus b plus b over t plus 2, so b is minus 1, so minus 1 over t plus 2. So we can easily find the integral of this expression. So we need to find the integral of 1 over t plus 1 minus 1 over t plus 2 times dt with respect to t, and we use the linearity property of integration. We separate the integration on both these expressions, so we get integral of 1 over t plus 1 with respect to t minus integral of 1 over t plus 2 with respect to t, and we can see that the expression written in the denominator has its derivative written in the numerator. T plus 1 has the derivative 1 because we are taking t has derivative 1 and constant has derivative 0. So similar is the case with this t plus 2. Its derivative is also written in the numerator. So the integration of these expression is simple. Natural log of t plus 1 minus natural log of t plus 2. And this is not the final answer because it is in terms of t. Our question was in terms of theta, and we used the substitution, Weierstrass substitution. T is equal to tan theta by 2. So we need to replace t with tan theta by 2. So natural log of the final answer will be natural log of tan theta by 2 plus 1 minus natural log of tan theta by 2 plus 2 plus the constant of integration.